For centuries, humanity has dreamed of predicting the future. Imagine being able to foresee everything, winning the lottery, knowing the weather for your wedding day, or avoiding traffic jams before they even form. From ancient oracles gazing into crystal balls to modern supercomputers crunching numbers, our fascination with what lies ahead has shaped civilizations, sparked scientific revolutions, and defined our relentless curiosity. But let's be honest, can we ever truly predict the future? Stephen Hawking, one of the greatest scientific minds of our time, explored this question in his book, Brief Answers to the Big Questions. From determinism and chaos theory to quantum mechanics and artificial intelligence, Hawking takes us on a journey through the limits and possibilities of prediction. Let's dive into what he discovered. Let's start with a time machine back to the 17th century and Isaac Newton's world. Newton was like the ultimate rule maker of the universe. He introduced laws of motion and gravity that made everything, from the orbits of planets to the fall of an apple, seem completely predictable. In Newton's view, the universe was a giant, perfectly ticking clock. If you knew the position and speed of every particle in existence, you could calculate exactly what would happen next, no surprises allowed. Sounds simple, right? Well, not so fast. Stephen Hawking points out that Newton's neat and tidy universe didn't hold up forever. Sure, the math worked great for simple systems like a swinging pendulum or a planet's orbit. But as soon as things got messy, think weather patterns or ocean currents, Newton's equations couldn't handle the chaos. This is where our story takes a sharp turn, straight into chaos theory. Now, chaos theory might sound like something out of a sci-fi movie, but it's actually very real and very humbling. In the 20th century, scientists like Edward Lorenz discovered that even small changes in a system can have massive, unpredictable consequences. Lorenz famously called this the butterfly effect, asking whether a butterfly flapping its wings in Brazil could eventually cause a tornado in Texas. It sounds dramatic, but the idea is surprisingly simple. Small things matter. A tiny shift in initial conditions can lead to wildly different outcomes. For example, when you play pool, a slightly off-angle shot can change the entire game, sending the balls bouncing in unexpected directions. Hawking explains that chaos theory doesn't break Newton's laws, it just highlights their limits. The universe might be governed by strict rules, but good luck trying to account for every little detail. Weather forecasts, for instance, are great for a few days, but after that they start to fall apart. It's not that meteorologists are bad at their jobs. It's just that the system is so complex that long-term prediction becomes nearly impossible. If chaos theory feels overwhelming, wait until we shrink down to the quantum world. Here, everything gets really weird, really fast. At the smallest scales of reality, particles like electrons and photons play by a completely different set of rules. Enter Werner Heisenberg and his famous uncertainty principle. Picture this. You're trying to find out exactly where an electron is and how fast it's moving. But the moment you focus on its position, its speed becomes a mystery, and vice versa. It's like trying to simultaneously track a hyperactive toddler in their trail of destruction. You can't do both at once. Hawking loved this quirky side of nature. He explained that this uncertainty isn't just because we lack good tools, it's baked into the fabric of the universe. At the quantum level, the future isn't a single fixed path. Instead, it's a cloud of probabilities. Sure, we can predict the likelihood of where an electron might show up, but we'll never pinpoint it exactly. It's as if the universe itself is playing dice, a notion even Einstein famously struggled to accept. Okay, so chaos and quantum mechanics have thrown a wrench in our plans to predict the future. But let's zoom out and look at something even more mind-boggling: complexity. Think about the human brain. With nearly 100 billion neurons firing off electrical signals, predicting what someone will think, feel, or decide is like trying to predict the weather on Mars next Tuesday. Even if we understand how individual neurons work, the sheer number of interactions creates a level of complexity that's almost unfathomable. Hawking explains that this phenomenon, called emergence, applies to more than just brains. Ecosystems, economies, and even traffic jams all exhibit behaviors that arise from countless small interactions. It's like baking a cake. You know the ingredients, but once they mix and rise in the oven, you get something entirely new. Complexity adds another layer of unpredictability to our universe, one that even our best models struggle to capture. Now, just when things seem hopeless, here comes a potential hero: artificial intelligence. Hawking saw AI as a game changer in our quest to predict the future. Why? Because AI isn't just smart, it's fast. It can process mountains of data and spot patterns that humans would never notice. For instance, AI is already helping doctors predict disease outbreaks, economists forecast market trends, and scientists model climate change. It's like having a superpowered assistant that never sleeps or gets distracted. But, as Hawking warns, AI is far from perfect. Imagine teaching a robot to predict what people will buy at the grocery store, but your data only comes from one neighborhood. The robot might become an expert on that area but totally fail when faced with a different crowd. AI is only as good as the data it's trained on. And let's not forget the black box problem. Many AI systems are so complex that even their creators don't fully understand how they make decisions. AI might be a powerful tool, but it's not a magic crystal ball. It can help us make educated guesses, but it can't overcome the chaos, complexity, and quantum uncertainty of the universe. This brings us to the big, philosophical question. If the universe follows physical laws, does that mean everything is predetermined? Is free will just an illusion? Hawking didn't shy away from this debate. He suggested that while the universe may be deterministic at its core, the sheer complexity of human behavior makes precise prediction impossible. So while we might not have free will in the traditional sense, we still experience it in our day-to-day lives. In other words, even if our choices are shaped by the universe's laws, what really matters is that they feel free to us. So can we predict the future? Stephen Hawking's answer is both yes and no. Sure, we can make educated guesses, build sophisticated models, and use AI to uncover patterns. But when it comes to absolute certainty, the universe has other plans. Chaos, quantum mechanics, and complexity ensure that some mysteries will always remain. But maybe that's not such a bad thing. After all, as Hawking reminds us, the journey of discovery is what truly matters. Predicting the future might be impossible, but trying to understand it pushes us to expand our horizons, refine our tools, and embrace the unknown. And let's be honest, would life be nearly as exciting if we knew exactly what was going to happen next?